So, a staple in the laboratory, many people take it for granted, is density, right? We often use density for multiple purposes, especially when we make solutions and standards. The density really comes into play whenever we are trying to relate grams and milliliters to each other. So, let's say that the solution that we're working with or that we want to make, let's say that it comes into us with a liquid form. We have to dissolve a liquid into a solution. Very often these calculations are based in gram or amount and not volume, so we have to use density in order to convert that liquid into a gram. Or let's say that we calculate how many grams of something like acetone that we need to weigh out. Well, I can go over to the balance and add acetone to a beaker and get a weight. Or if I knew the density for acetone, I could quickly convert that over to a milliliter and then figure out how much to pipette instead of weigh out. So that's where density really comes into play in the solution and standards world. So I just want to do a quick review on calculating density and maybe how to use this number in various calculations. So the very first thing that I need to remind you of is that density is grams per milliliter only for a liquid, people. That is it. If it's not a liquid, then it's not gram per mil. So if I have a solid that I'm trying to get the density of, most of the time it's grams per cubic centimeter. Cubic centimeter, over here to the side, I'm going to quickly write 1 mil is equal to 1 cubic centimeter. They are the exact same. So even though that the unit is different, the number is typically the same, whether it's gram per mil or gram per cubic centimeter. Those units are identical, right? And then finally, if we have a gas densities are typically given in grams per liter, and that's just because gases are so lightweight. The molecules hate each other, they can't stand each other, they're really far apart, unlike the solid and the liquid. So it kind of takes more of a gas in order to weigh it out to get a substantial amount to work with. So gram per liter is the unit for density for a gas. Okay, so how do we calculate it? Well, if we calculated the density of a liquid, it's pretty easy. The only thing that we have to do is take a sample with a known amount of volume, of course, and we would weigh it on an analytical balance. So let's say that I took 5 milliliters of a solution and I put it on the scale, and that 5 milliliters, the weight of that was 4.125 grams. And the question wants me to calculate density. Well, if I remember, density is grams per milliliter. That's really all that we got to do. Remember, grams per mil. Then to calculate density over here, 4.125 grams over 5 milliliters, right? And there's my grams per mil unit. That's what I need. That's why I set it up that way. So I'll take 4.125 and I'm going to divide that by 5, and that gives me 0.825. And that's gram per mil. And that's how I would calculate density of a liquid, right? It's no more than that. That's all there is to it. In a laboratory, we actually make things a little bit simpler. In a lab, we most of the time will use 1 milliliter. And let's say that 1 milliliter weighs 0.634 grams. Well, if I take my gram, 0.634, and divide it by my volume of 1 mil, there's my gram per mil, right? So that's 0.634 grams per milliliter. That's why we do that in a lab, because if we can measure out 1 milliliter of liquid and weigh it directly on the balance, we automatically get the density. We don't have to do an extra calculation, because anything divided by 1 is that same exact number. So it's quick, it's easy, it's painless, there's no calculator involved. Whenever we do that in a lab, that's what we do. So that's what I encourage you to do as well in a laboratory. If you are just given the task to calculate density for something, or to obtain the density for it, and you have to do it by hand, just take 1 milliliter of the stuff and add it directly to a tiered weight, and whatever mass shows up on the screen, that's also the density of that molecule as well, or that substance or that solvent. Okay, if you had a solid, let's say that this is an irregular solid, you'll very rarely see this in a lab, but let's say that we've got some kind of cube or some kind of box or some kind of shape. If it's something that's straight lines that I can measure, we always take the width times the length times the height. And we want to make sure that these are in centimeters every time, because only if they are in centimeters will it work out to be cubic centimeter in the very end. So to calculate the volume, you would take length times width times height. So you would multiply all three values in terms of centimeter, and you would get the volume. Then you would take the mass of this object, whatever that object would be. You would take that mass, divide it by the length times width times height, and that will give you the density of that particular substance. If it wasn't a regular shaped object, let's say it was an irregular shaped object, and it's just a big old clump of something, what would happen is that you will still need the density for it, right? So you would take something like a graduated cylinder, and you would fill it full of some water. And let's say that water, the bottom of the meniscus here, let's say starts on the 4 milliliter line. Okay, you would take that clump and you would put it into the graduated cylinder, and this would basically raise up a little bit. And this is what we would call the displacement. So let's say it goes to 6 mils now instead of 4. So this is what we would call the displacement, but this is also the volume, the amount of space that this object takes up. So we would weigh the clump, and then we would do a volume displacement in order to measure the volume. You would then take the gram, the mass of it, divide it by the volume from the displacement, and you would calculate density that way as well. And then finally, gas. If you can do a liquid and a solid, you can do a gas as well. So again, it's the mass of the gas and the liter that you're putting that in. So as long as you understand it's liter this time and not milliliter, then you'll be okay. Just make that necessary conversion and you'll be fine. So that's all there is to density, and that's really all that we have to say. I'm not going to do any example problems as far as the solid and as far as the gas goes, because we rarely have to do these in a lab. I'll let Chemistry 151 and 152 worry about those kinds of setups. We're focused on what's traditionally seen in a laboratory, and that's liquids. So as long as you understand measuring out a volume and getting its mass, taking those two numbers and dividing them, we're good. That's all that we need to talk about as far as density is concerned. However, the other half of this discussion is going to be how to use density. So let's say that I have a solution, and that solution has a density, which is D. That's what it's found in the Merck. Let's say the density of that is 0.731 gram per mil. And let's say that I'm given a problem, and that problem is the lab requires 2.441 grams of substance. I could take the liquid and I could take it directly to a scale, and that scale would give me the weight. And I could weigh it out, just directly weigh it out. And then I don't have to worry about any type of calculation. Sometimes the problem, though, is that these substances are very volatile. And if I take my time and weigh out things on a weigh boat, or let's say that it will eat the plastic of the weigh boat, then that's not going to be a necessarily good scenario for me, right? If it eats the plastic, I'm not going to be able to get the liquid to where it's going to go. And if it evaporates on me quick, then I'm going to have to move pretty fast in order to get this proper amount of mass into my delivery container. So very often we've got to use density in order to convert that to a volume. How much volume should I weigh? Because I can suck that stuff up with a pipette. It's in a closed container, it's glass, and it's not going to go anywhere, right? So how do I do that type of problem? Well, let's say I've got 2.441 grams over 1. Set it up just like dimensional analysis. Gram on top, gram on bottom, and I need to go to milliliter. So with this substance, the density is 0.731 gram per 1 milliliter. So there's my gram. So 0.731 gram per 1 mil. So 1 goes there. So now I'm going to take my mass, which is 2.441, and I'm going to divide that by 0.731. And I hit enter, and I get 3.34 rounded off. So 3.34 milliliters is what I would basically volumetrically pipette out and put it into my container that it's eventually going to go to make a solution with. So that's how we would use density in a real life kind of scenario or a real life event. It helps me understand the relationship between the amount and volume. For whatever reason that I need that, it helps me determine that. All right, so let's do one more example. Let's say that the density of the solution that I'm working with is a 0.421 gram per mil. And let's say that I have measured out 6 milliliters of this substance. How many grams am I using in the laboratory, right? That's very important because maybe I want to take that gram and convert it to mole and use the mole number for whatever other calculation that we've talked about up to this point. So I'll set my dimensional analysis up, 6 mils over 1, right? Bring in your extra step, mil on top, mil needs to go on bottom, and I need to go to gram. I know that gram to mil is related by density. So 0.421 grams, there's my gram, so 0.421 grams per 1 mil. So 1 is going to go there. So I'll take my 6 and I'll multiply it by 0.421 and I hit enter. And I'm going to get 2.526 grams. So 2.53 or 26, however you want to do it, significant figures, whatever, I don't care, 2.53 grams of substance. So if I've measured out 6 mils, I've got 2.53 grams of the stuff that I'm working with that I can then use and convert that number into something else if I need to, right? So that kind of takes me back to this roadmap that we began talking about. So gram to mole is great if we have formula weight, and it can go both ways, right? And then we said mole to molecule or atoms or ions, whatever that number has to be, as long as I know Avogadro's number, 6.022 times 10 to the 23rd, and that can go both ways. Now we can actually add on another step here. And I can go from gram to mil or mil to gram as long as I know the density of the substance that I'm working with. So the road got a little bit bigger and my choices got a little bit more varied, right, of what I can do with these things as far as where I need to go and where I'm starting with. Notice that milliliter cannot be directly connected to mole. You have to go to gram first. And milliliter cannot be directly attached to molecule. You actually have to go to mole. Then before that, you got to go to gram. So that's going to be a couple of extra steps that are there. So keep that in mind with the dimensional analysis. So in this upcoming assignment, what you'll see is a few density problems. Here's the volume. Here's the gram. What is the density? I might throw in a gas density. Here's the volume, here's the mass, what's the density? Just keep in mind that that has to be based in liter. And I might throw in a solid density problem. Here are your measurements of width, and height. So use that to calculate for your volume, and then calculate density from that. And then the second half of the assignment will turn a corner, and that second half will be basically these types of questions. If you are using this amount, how many grams do you have? If you're using this amount, how many milliliters do you have? And I can even throw in now a little bit of combination problems. So if you're using this amount of milliliters, how many moles of that substance would you have? So I'm going to do one of those examples just so that you've got something to go by, but they're no different than the other setups that we've done before. Okay, all of these are kind of running in together. And that's a good thing, not a bad one, by the way. So let's say that I have a density of a liquid, and that density 0.8765 grams per mil. And let's say that this substance is benzene. So benzene is an organic molecule, meaning mainly carbon and hydrogen, and there's a double bond and a double bond and a double bond. So it's a rotating double bond, single, double, single, double, single. We call that conjugated system. And then shorthanded, we don't really like to draw the double bonds. We just like to draw a circle. So there's the structure for benzene. Keep in mind that every one of these little corners, here, 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 and here, those are carbons, and then there's enough hydrogens on those things to make each carbon have 4 bonds. So we actually have a hydrogen that's coming here, and one there, one there, one here, one there, and one there. Because look, this carbon, 1, 2, 3, and 4. Now all the carbons have 4 bonds all the way around. So the formula weight for this thing, and you'll see why I'm writing that down, is 78.11 gram per mole, right? So let's say that we obtain 2 milliliters of benzene in a laboratory. And I want to know how many moles of benzene would that be, right? So mole is kind of the key term. Now, that's what relates everything in chemistry or a laboratory environment together. So I've got to use volume, and I've got to figure out the amount in the proper unit that we need to be discussing so we can compare apples to oranges, right? Okay, so this is how I'll do it. So I've got 2 milliliters, and that's my given. So I put that over 1, and I bring in my next step. Well, milliliter on top, milliliter on the bottom. And we now know, just a while ago, that milliliter can only be related to gram. And that's it. And in order to do that, I need density. Well, my density is right up here at the top, 0.8765 grams per 1 milliliter. So 0.8765 grams per 1 mil. So now I bring in another dimensional analysis step. Gram on top, gram on bottom. And now I need to go to mole because that's what the question wants me to do. So gram and mole, how are they connected? Well, they're connected by the formula weight right over here. 78.11 grams per 1 mole. So in 1 mole, there's 78.11 gram. Always keep the number with the unit and you'll be okay. And that's really what the question wants, right? I've got 2 mils. I want to know how many moles am I working with in the laboratory. So I'm going to take 2. And then I'm going to multiply by 0.8765, so times 0.8765. And then I'm going to divide that, because that number's on the bottom, I'm going to divide that by 78.11. And that number will be moles of substance that I'm using. So 0.0224. Moles of benzene. Okay? All right, so that's all there is to density. Those are the types of problems that we would see. Just keep in mind it's a conversion factor. That's all that it is. It's a conversion factor that allows me to go from gram to mil and vice versa. So good luck on the upcoming assignment. I think that this is going to be pretty simple for you. Just go back to the basics, do some density calculations, maybe bring in an extra step now that you know how to relate grams and mils and moles and all of these things together, and you'll do perfectly fine. So make me an A. That's what we're after. Good luck. If you have questions, let me know.